Welcome back, everyone. Today we're taking a deep dive into the life and work of, well, I'm sure you guessed it from the title, Isaac Newton. But we're going beyond those classic stories, the falling apple, the laws of motion, trying to get a deeper understanding of the man, his motivations, his complexities. And we have this really fascinating biography here to help us do just that. Get this, it's in Spanish. So we might uncover some unique perspectives, things that maybe haven't been as widely discussed.
Yeah, that's what's always so interesting about exploring these figures,
Yeah.
these towering giants of science. We often forget they were real people, right, with their own quirks and struggles.
Totally. And the book really dives into Newton's childhood, which it wasn't exactly a walk in the park. He was born premature. His father died before he was even born, and then his mother remarried and sent him to live with his grandmother. I mean, you have to wonder how those early experiences shaped him.
Yeah, for sure. It's something to consider. I mean, think about it. This biography actually talks about this incident from his childhood, a fight he had with a bully. And the bully just happened to be the son of the local schoolmaster.
Oh, right. I remember reading about that. It sounds like young Isaac had a bit of a temper on him.
He did. But the thing is, he was smaller than this bully, but he still won the fight.
Yeah.
And get this, the bully's father, the schoolmaster, actually encouraged Newton to humiliate his son even more after the fight was over.
Wow, that's intense. Do you think there's any connection between this childhood story and how Newton was later in life? Especially how competitive he was in the scientific community, all those disputes he had?
Hmm. It's hard to say for sure, but it's possible. This incident, even though he was so young, it hints at this, deep-seated need to assert dominance to come out on top.
It's like that early fight was a preview of the battles he would later wage. But instead of fists, it was ideas.
Exactly. And the book also talks about this collection of Newton's early writings, the Quaderno Fitzwilliam.
Oh, yeah, right. That's where he kept that list of his sins, isn't it?
It is, and some of those entries are pretty revealing.
I mean, some are kind of normal, like eating an apple before it was ripe or being peevish with my mother. But then there are others that are a bit more, I don't know, disturbing.
Yeah, like the one where he confesses to threatening my father and Mother Smith to burn them in the house over them.
Yikes.
Right. I mean, it's pretty dark stuff.
It makes you realize that even brilliant minds are capable of pretty intense, even unsettling emotions.
Absolutely. But to understand Newton and his work, we need to shift gears a bit. Talk about the scientific landscape during his time. Because remember, he wasn't working in a vacuum.
Right. There was this huge revolution going on in astronomy. The old geocentric model with Earth at the center was being challenged by the heliocentric model, where the sun took center stage.
Exactly. And Copernicus was really a key figure in that shift. His book, De Revolutionibus Orbium Coelestium, published in 1543, really laid the groundwork for the heliocentric model.
I mean, imagine how radical that idea must have seemed back then, the Earth not being the center of everything.
Right. But even with the heliocentric model gaining traction, there were still so many questions, like how exactly do these planets move around the sun?
So that's where Kepler comes in.
Yes, Johannes Kepler. Using these incredibly precise astronomical observations that Tycho Brahe had made, Kepler formulated his 3 laws of planetary motion.
Okay, gotta be honest, Kepler's laws always make my head spin a little. Maybe we could break them down, for anyone listening who might need a refresher.
Sure. The first law, it states that planets don't actually move in perfect circles around the sun. They move in ellipses.
Right, like a slightly squashed circle.
Exactly, with the sun at one of the 2 foci of that ellipse. Now, the second law, sometimes called the law of equal areas, it tells us that a planet sweeps out equal areas in equal times as it orbits the sun.
So that means when a planet is closer to the sun, it moves faster, and when it's farther away, it slows down, right?
Exactly. And then the third law, it connects a planet's orbital period, the time it takes to go around the sun, to its average distance from the sun. Basically, the farther away a planet is, the longer it takes to complete an orbit.
Okay, yeah, it's all coming back to me now. So these laws, they described how the planets moved, but not why.
And that's where our boy Isaac Newton comes in.
To explain the why. And I guess we have to talk about the apple, the one that supposedly fell on his head and gave him the idea for gravity. Any truth to that story?
Well, the apple story is probably more myth than reality. I mean, it's likely that Newton, like all of us, observed things falling. And maybe that sparked some of his thinking. But developing the theory of gravity was a long and rigorous process. Years of work.
So no sudden eureka moment.
Probably not. Our biography actually goes into a lot of detail about the calculations and deductions. The real nitty-gritty that led Newton to his breakthrough.
And that's what makes the Spanish biography so interesting. It goes beyond the simple stories and shows us how he actually arrived at his ideas.
Exactly. Because he didn't just, pull the law of gravity out of thin air.
Let's rewind a bit. Newton spent some crucial years at Woolsthorpe, from 1665 to 1666. What was he up to during that time?
Well, he was deeply immersed in the works of Descartes and Galileo, really grappling with the concept of inertia.
Right, that an object in motion will stay in motion unless a force acts on it. Didn't he say something like, if I have seen further, it is by standing on the shoulders of giants?
Exactly. He was acknowledging the importance of building upon the work of others, taking those existing ideas and pushing them further.
So what was Newton's next big step? How did he get from inertia to gravity?
Well, it's fascinating. He used Kepler's third law of planetary motion, and he deduced the inverse square law of centrifugal force.
Okay, you're going to have to break that down for me.
Sure. Imagine you're swinging a ball on a string. The faster you swing it, the stronger the outward force.
Right, like it wants to fly off in a straight line.
Exactly. That's centrifugal force. And what Newton figured out was that as the distance from the center increases, the force decreases rapidly.
Like if you double the length of the string, the force becomes 4 times weaker.
Exactly. It's an inverse square relationship. And this realization was huge for him.
So how did he connect that to gravity, to the force that holds planets in orbit?
He started thinking, what if the force pulling the moon towards the Earth and the force pulling an apple to the ground are actually the same force?
Whoa, that's a mind-blowing connection.
It was. It unified the celestial and the terrestrial, showing that the same laws of physics applied everywhere.
But this wasn't just a sudden flash of insight, right?
Of course not. It was years of testing, refining, developing the mathematical tools.
So he didn't just have the idea, he had to prove it.
Exactly.
And all of that led to his masterpiece, the Principia Mathematica.
Published in 1687, one of the most important scientific works ever.
It laid the foundation for classical mechanics.
And introduced the world to the law of universal gravitation.
But there were some bumps along the way, right? Didn't he have that whole dispute with Robert Hooke?
Ah, yes, the Hooke affair. It shows us a different side of Newton, how fiercely he protected his work.
So what happened exactly?
Well, Hooke claimed that he had given Newton the idea for the inverse square law, and he was very vocal about it.
How did Newton take that?
Not well. He even threatened to not publish the Principia at all.
Oh, wow, that's high stakes.
In the end, he did acknowledge Hooke's contributions in the book,
Yeah.
but in a very grudging way.
So, despite all the drama, the Principia finally gets published. What kind of impact did it have on the scientific world?
It was a game changer. It gave a unified explanation for motion, both in the heavens and here on Earth.
Something no one had done before.
It could explain the tides, even the precession of the equinoxes.
Wait, the precession of what now?
Basically, the Earth's axis wobbles a bit, like a spinning top as it slows down.
I had no idea.
It takes about 26,000 years for the Earth to complete one wobble.
So Newton's theory could explain these incredibly subtle things.
It was powerful. It worked. And its success was even further solidified by the discovery of Neptune.
Hold on, how did Newton have anything to do with that? I mean, Neptune wasn't discovered until over a century after his death.
It all comes down to his law of gravity. Astronomers had noticed that Uranus's orbit wasn't quite behaving as predicted by Newton's laws.
So they thought maybe there's another planet out there messing with its orbit.
Exactly. And they used Newton's laws to calculate where this hypothetical planet should be.
And lo and behold, Neptune was discovered right where they predicted.
It was like a cosmic confirmation of Newton's work.
Talk about leaving a legacy.
But like any scientific theory, it's not perfect. There were things Newton's laws couldn't quite explain.
Like what?
Well, one notable anomaly was the perihelion shift of Mercury.
Okay, now you've lost me.
The perihelion is the point in a planet's orbit where it's closest to the sun. And astronomers observed that Mercury's perihelion was shifting slightly over time, more than Newton's theory could account for.
So this tiny discrepancy hinted that there was something more to gravity.
Exactly. It was a clue that a more complete theory was needed.
And that's where Einstein enters the picture, with his theory of general relativity.
Yes. Einstein's theory provided a more refined model of gravity, one that could account for Mercury's weird behavior.
But didn't Einstein still acknowledge Newton's contributions?
Absolutely. He said that for most everyday purposes, Newton's theory was still incredibly accurate.
So it's like Newton built the foundation and Einstein built upon it.
That's a great way to put it.
It's amazing how scientific knowledge builds upon itself.
It's a collaborative effort that spans centuries.
We've covered a lot of ground here, from falling apples to planetary orbits to the limits of Newton's physics. But it feels like we've only scratched the surface of this guy.
You're right. We haven't even talked about his work in math, his fascination with alchemy, or his theological explorations.
Sounds like the man had a lot going on.
He did. He was a true polymath.
Well, it seems like we have a lot more to unpack. Stay tuned, folks, because we're going to delve into the many faces of Isaac Newton.
So ready to explore some other sides of Newton, maybe some you wouldn't expect from the guy who figured out gravity.
Yeah. We've seen the groundbreaking physicist, the guy who revolutionized our understanding of, well, the universe, really. Now I kind of want to meet the other Newton. The mathematician, the alchemist, the theologian.
That's a good way to put it. He was so much more than just planets and forces.
Okay, so let's start with math. We can't talk about Newton without talking about calculus, right? I mean, it's like Physics 101 wouldn't exist without it.
It's true. Calculus, as we know it today, owes a lot to Newton. But of course, there's that whole debate with Leibniz about who really deserves credit.
Ah, yes, those priority disputes. Newton seemed to have a knack for finding himself in the middle of those.
He did.
Too.
But putting all that aside for a second, Newton's invention of calculus was a huge deal. I mean, it gave us this incredibly powerful tool for understanding change in motion.
Completely changed the game for math.
And it even enabled many of his other scientific discoveries.
So while he was busy figuring out gravity, he was also inventing entirely new areas of math. The man's brain must have been working overtime.
He was brilliant, no doubt about that. But calculus was just one piece of the puzzle. He also made significant contributions to algebra, geometry, you name it.
It's almost hard to believe one person could do so much. But you know what I find really interesting? His fascination with alchemy. It seems a little strange, right? The father of modern science. Interested in something that, well, we now consider pretty unscientific.
It might seem strange to us now, but remember, in Newton's time, alchemy was a respected field.
So it wasn't just a bunch of people trying to turn lead into gold.
Well, maybe some were. But I think for Newton, it went deeper than that. He was fascinated by the nature of matter, the fundamental building blocks of the universe.
And alchemy, with its focus on transformation and the properties of substances, it offered this unique way to explore those ideas.
Exactly. And our Spanish biography talks about how he conducted tons of alchemical experiments. He even developed his own secret language to describe them.
The secret language. That's cool.
It's really interesting stuff. It's a reminder that back then, the lines between science and mysticism were much blurrier.
It makes you wonder what he was really searching for in those experiments.
Right. Was it purely scientific knowledge, or was there something spiritual driving him as well?
I guess we'll never know for sure. But speaking of his spiritual side, let's talk about Newton, the theologian.
He was a deeply religious man, that's for sure.
But how did he reconcile that with his scientific work? It seems like kind of a contradiction.
It might seem that way to us, but for Newton, science and religion weren't at odds with each other. He saw them as complementary paths to understanding the universe.
So studying the natural world was a way to learn more about God's creation.
Exactly. And our biography points out that he actually had some pretty unconventional theological views, even for his time.
Like what?
Well, for one, he rejected the doctrine of the Trinity, which was a pretty controversial stance. He also got really into biblical chronology, trying to create a timeline of historical events based on his interpretations of Scripture.
It's like he was applying his scientific mindset to everything.
It seems that way. He was searching for a unified understanding of the universe, a grand synthesis of knowledge that encompassed science, math, history, theology, everything.
It's amazing how his mind could seamlessly move between all those different areas. But I wonder, did he ever find the answers he was looking for? Did he achieve that grand synthesis?
That's a tough question. But what's clear from this biography is that Newton's quest for knowledge never ended. He never stopped asking questions, never stopped searching.
Okay, so we've got Newton the mathematician, the alchemist, the theologian. What's the takeaway here? What's his lasting legacy?
Well, it's complex, just like the man himself. His contributions to science are undeniable. He laid the foundations for classical mechanics, changed how we think about gravity, optics.
And then there's calculus, a complete game changer.
Which is still used in countless fields today.
He was also president of the Royal Society, a real leader in the scientific community.
His influence went way beyond his own research. He helped foster a whole culture of scientific inquiry.
But of course, no legacy is perfect. There were those priority disputes, his treatment of rivals.
Right, it's a good reminder that even geniuses are human. They have flaws, make mistakes, get caught up in ego and ambition.
I think that's an important lesson from all this. To look beyond the simplified stories and recognize the complexity of these figures.
To see them not just as icons, but as real people.
With their own unique strengths, weaknesses, and motivations.
And I think understanding the human side actually makes their achievements even more impressive.
So we've seen the many faces of Isaac Newton. The physicist, the mathematician, the alchemist, the theologian. It's clear he was a man of extraordinary intellect and ambition, driven by this deep desire to understand the universe.
And his story is both inspiring and cautionary.
A testament to what the human mind can achieve, but also a reminder that brilliance can come at a price.
A perfect way to sum it up.
So here's a final thought for everyone. If Newton hadn't made these incredible discoveries, would someone else have eventually found them? Or was he truly one of a kind, a unique genius whose contributions were absolutely essential?
Yeah, that's the big question, isn't it? Was Newton just a product of his time, or was he something truly special?
It really makes you think, doesn't it? Trying to picture a world where Newton never existed.
Would we still have, calculus, the laws of motion, universal gravitation?
A world without those things, it's hard to even imagine.
Part of me thinks scientific progress is, inevitable in a way. Like, given the right circumstances, someone would have eventually made those discoveries.
That makes sense. Especially when you remember discoveries rarely happen in isolation. There's always this foundation of previous work, this chain of knowledge passed down through generations.
He knew that too, right?
Yeah.
Newton himself said, "If I have seen further, it is by standing on the shoulders of giants."
Exactly. He was building upon Copernicus, Kepler, Galileo, all the greats who came before him. So maybe those breakthroughs were just waiting to happen. But there's also the argument that Newton was just, different. A singular genius whose mind was just wired in a way that allowed him to see things others couldn't.
You can't deny he had a truly extraordinary mind. His ability to, synthesize information, see those connections, and then come up with these incredibly powerful mathematical tools. It was remarkable.
And you have to consider his drive, too, right? That almost obsessive dedication to his work.
Oh, absolutely. The stories about him spending days locked away in his study, completely consumed by his research, it's legendary.
That kind of passion, that single-minded pursuit of knowledge, it's pretty rare.
It really is.
So maybe the answer is somewhere in the middle. Maybe progress is inevitable in the grand scheme of things, but the specific path it takes, how fast it happens, that can be heavily influenced by individuals like Newton.
I think that's a really great point. We can appreciate the larger historical forces at play, but also acknowledge the incredible impact of these truly brilliant minds.
Because at the end of the day, it was Newton who took all those existing ideas, put them together, and created something completely new and revolutionary.
He gave us a whole new framework for understanding the universe.
And that's something we're still benefiting from today.
Without a doubt.
I think this deep dive has been a great reminder to, appreciate how complex history really is. How it's not just a straight line of progress, but a combination of individual brilliance, collective effort, and, a little bit of luck, too.
Absolutely. And remembering that these iconic figures of science were real people with their own flaws and passions makes their achievements even more meaningful.
Well said. Well, I think we've done a pretty thorough exploration of Isaac Newton today, from his, let's say, interesting childhood to those groundbreaking discoveries, and even those lesser-known pursuits like alchemy and theology. We've gotten a glimpse into a truly remarkable mind.
It's been a fascinating journey.
To everyone listening, if you want to learn even more, definitely check out the biography we've been discussing. There's always more to uncover, more to learn.
And who knows what amazing stories we'll dig up in our next deep dive.
Until then, stay curious and keep those questions coming.
See you next time.
Thanks for joining us.